Now we're going to talk about the probability concerning decks of cards. So a standard deck of 52 playing cards consists of 4 suits, and suits are hearts, spades, diamonds, and clubs. There are black and red colors in a standard deck. So the black cards are the suits, spades, and clubs, while the red cards are the suits, hearts, and diamonds. We also have rank in a deck of cards. Each suit contains 13 cards, each of a different rank. An ace, which in many games functions as both a low card and a high card, and cards numbered 2 through 10, as well as a jack, a queen, and a king. So here's our example 4. It says, compute the probability of randomly drawing one card from a deck and getting an ace. Well, since we know that there are 52 cards in the deck and there are 4 aces, so we could calculate the probability of getting an ace as being 4 out of 52. We can simplify this fraction to be 1 out of 13. And if we were to divide those numbers in the calculator, we would get approximately 0.0769. We can also think of probabilities as percents. So we could say there is a 7.69% chance that a randomly selected card will be an ace. Notice that the smallest possible probability is 0. If there are no outcomes that correspond with that event, we would say the probability is 0. The largest possible probability is 1. If all possible outcomes correspond with the event, then we would say the probability is 1, which is 100% likely to happen. Next, we're going to talk about certain and impossible events. So these go along with those probabilities we just discussed. An impossible event has a probability of 0. A certain event has a probability of 1. The probability of any event must be between 0 and 1. We will never have a probability that is negative or that is greater than 1. In the course of this chapter, if you compute a probability and get an answer that is negative or greater than 1, you have made a mistake and you should check your work. Now we're going to be working with events. So we have the next example, which says, what is the probability that we roll a 6 on a 6-sided die? And the second question is, what is the probability that we do not roll a 6? So the first one we can figure out pretty easily. The probability of getting a 6 is 1 out of 6. There are 5 outcomes that are not a 6, so the answer to the second question is probability of not getting a 6 is 5 out of 6. But notice that if we add the probability of getting a 6 with the probability of not getting a 6, we get 1/6 plus 5/6 equals 6/6, which is the same as 1. This is not a coincidence. Here's a generic example. N possible outcomes with an event E that corresponds to M of these outcomes, then the remaining N minus N outcomes correspond to E not happening. So in mathematical terms, we would write the probability of not E happening would be N minus M divided by N. If we broke up this fraction into 2 parts, we would have N over N minus M over N. And N over N can simplify to the number 1. And then if we replace M over N with the probability of the event E happening, we would get 1 minus the probability of E. So this is why this is not a coincidence. We can calculate what we call the complementary probability of pretty much anything by subtracting it from 1. The next concept we will talk about here is the complement of an event. So like I was just saying, the complementary probability is subtracting the probability from 1. So the complement of an event is the event that E doesn't happen. E bar, with a little line on top of the E, we call that E bar, is the notation used for the complement of E. And so if I want to find the probability of E bar, I just simply subtract it from 1. 1 minus the probability of E. Or if I wanted to find the probability of E, I could subtract the probability of E bar from 1. So 1 minus probability of E bar. You'll get used to this notation. It is a little different at first, but just remember that the complementary probability plus the regular probability should add up to 1. It should be 100%. So if you find the percent that an event is likely to happen plus the probability that it's likely to not happen, that should add up to 100%.